Hello, welcome, both on-site and virtual participants of the IDW 2022. My name is Wansik Jeff Shim, and I'm chairing this portion of the IDW plenary session. Okay, we have come to the last plenary session of the IDW 2022. Yay! The title of the session is Empowering and Enabling Society, Data Science and Data Stewardship, Education and Data Literacy. It's quite a mouthful. This is the last official program before the closing session, and there's a good reason why we placed this session at the end. Whatever human enterprise we engage in, it all begins with people and ends with people. In this session, we take a stock of what we are doing in the area of training and educating data professionals. This is also a great opportunity to pause and think about how best we can train the next generation talents in the field of data. Our view of data professionals is very broad. However, while different degrees and training programs for data analytics, part of data science, are spreading like wildfire, the need for training other essential professionals in the whole data ecosystem is not widely recognized beyond some circles. So in this session, we have invited 3 outstanding experts to talk about their experience and insights related to the topic. As you will see, they come from quite different settings and speak to a wide audience. During the IDW 2022, we already had a number of sessions that directly or indirectly address the area of training and education. So our session needs to be considered as something that complements what has been already discussed in those sessions. You may have already read the bios of the speakers, so I'm not going to read their colorful resumes and accomplishments. Instead, I'll show each speaker's summary bio before you meet them shortly over Zoom. Yes, all 3 speakers really wanted to participate in person, but in the end, here we are in the virtual space. Okay, so I'm going to show you, because since you can read it, okay, this is our first speaker, Michelle Barker, okay, and the report she co-edited with other people. And this is second speaker, Marianne Grootveld, from the Netherlands at Dans. And she also co-authored one of the influential report related to the topic. And finally, we have Dr. Jevin West, who is, I think he's in the West Coast, and the time now is about 12 midnight. So I feel sorry for him to put him in a really difficult spot, but I'm so glad he joined us with us today. And he co-authored this book called Calling Bullshit, and I can show you that I have a Korean translation with me. Okay. So, all right, the order of presentation is by their last names. Each speaker has about 15, 17 minutes, so we can have time for question and answer at the end. So I believe the speakers are now all ready. Our first speaker is Dr. Michelle Barker. Michelle, please take it away.
Thanks, Jeff. Let me just get my screen sharing started. Hopefully you can now all see my talk. So firstly, thank you for this invitation to speak here at IDW. It's an honor to share the stage with my esteemed colleagues and a fantastic opportunity to engage with so many of you in the audience who share this passion that Jeff so well elucidated in his introduction, for the people who make research happen. My name is Michelle Barker, and I'm the director of the Research Software Alliance. And I'll be talking about ways to support and recognize research software skills and personnel. As Jeff explained at the beginning, there's a wide diversity of roles and skill sets emerging that are needed to support digitally enhanced research, including those people who analyze the data and provide tools for that, which is, of course, research software. To give you just a brief outline of the things I'll be covering in the next 15 minutes, I'll be talking about why it's so important to recognize and support research software personnel and those skill sets. I'll be talking about some of the challenges and barriers that they face, and then giving some concrete ideas taken from examples happening around the globe and in different disciplines of ways in which you or others that you work with could also improve support for recognition in this area. And finally, I'll just touch briefly on my organization, the Research Software Alliance, and the role that we play in this space. We're all aware that there's been a growing emphasis on digital skills and the need for that in the research sector. Last year, we saw the UNESCO recommendation on open science finalized, which included as its fourth recommendation, investment in human resources to build capacity for open science. The European Open Science Cloud has as its first objective to ensure that open science practices and skills are rewarded and taught, becoming the new normal that is entirely focused on the people element. And in 2020, the OECD culminated for 2 years of work to release a report on building digital workforce capacity and skills, which I chaired. To explain a little bit what a digitally skilled research workforce might look like, the kinds of skills and possibly some of the job titles that are continuing to grow. On the left here, we have a diagram of a number of different hexagons, which shows 6 of the commonly recognized elements of open science. So we're going to need people with skill sets and perhaps dedicated roles to support all of these elements: open data, open educational resources, open access, open peer review, open methodology, and most relevant to my talk today, open source or open software. The diagram on the right shows another way of explaining this. It identifies a few of the different skill sets that we need and some of the most common job titles. So I'll be talking specifically about the skills that researchers need, as we now live in a world where most researchers benefit from being able to do at least a little bit of code. For some of them, it's integral to their work, particularly if there's some from particular disciplines. But there's also emerging professional roles, such as the research software engineer, that are dedicated to this nexus. To explain a little bit more about why research software skills and personnel are so critical, these are some highlights from some reports over recent years. Some of their headlines: it's impossible to conduct research without software, says 70% of UK researchers, and 50% of those develop software as part of their research. Software-intensive projects comprise the majority of current publications. And finally, a picture on the right, a recent Nature article or blog perhaps, on why science needs more research software engineers. To explain this term, research software engineer, and what it is, there's a range of people who can code in the research ecosystem. So on the vertical axis there in orange, we have people who are professionally qualified software engineers who probably have some kind of academic qualification in IT. On the horizontal axis in blue, we also have researchers who've primarily focused on innovating in a particular discipline or disciplines, but may have developed some interest in coding, or it may have been a mainstay of their degree. And in the middle, we have a whole range of people who have varying degrees of both. And the research software engineer can sit anywhere in that continuum. Commonly, they are, in fact, researchers who have been skilled or particularly passionate about coding, and then have enhanced their understanding of software engineering. But it can also happen in reverse, that people who have been software engineers specializing in that focus then have engaged heavily with a number of research disciplines or a particular discipline, such that people coming from either ends of the spectrum can end up with this unique skill set on being able to advise on how to apply coding and develop software for research in a very wide range of contexts. I thought it might help to define what I mean by research software. So this is a definition that was agreed to after extensive community consultation. It defines research software as codes, etc., that were created for the, sorry, my picture's over my slide, I just can't read that, are created during the research process or for a research purpose. So something like Microsoft or OpenOffice that certainly provide software tools that many researchers use do not fit this definition. To reflect a little on the barriers and challenges that we face in supporting people with these skill sets, I thought I'd ask you to think a little bit about your own experience. Do you know anyone with these skills? Are there people in your team? Are there a group of people in your organization with these skill sets? Do you know people who actually have this as their primary role? And they may have a job title like research software engineer or something related to a discipline like bioinformatician. But they may also have a role that makes it completely ambiguous as to what level of coding skills they have. Their job title could be PhD student or postdoc or lecturer or professor. All are equally valid. And an Australian study recently identified about 80 different job titles for people who do a bit of research software engineering or a lot. So certainly it can come within a diversity of roles. So if you think about some of those people that perhaps you engage with, maybe directly in your research team, or that you see available in your institution or in other parts of the national sector, is it clear how their software contributions to research are recognized? Because the software or the code that they development is equally an output of research that deserves the same recognition in publications. Is it clear that there are career paths for them that embrace and celebrate that they have these skills in software development? My guess is that whilst I'm sure some of you are answering yes, there are emerging, increasing opportunities for recognition of software and career paths are beginning to develop. On the main, there are still enormous challenges in ensuring that we recognize this new skill set, this function in research teams and the research ecosystem, and ensure that they are supported. So to give you some ideas on how to achieve change, I'm going to use a strategy for cultural change from Brian Nosek, which says change is needed at 5 levels: at policy, incentives, communities, and I'm going to rename user interface experience there as skills and training, and finally, infrastructure. These are some examples of things that organizations or countries or disciplines are doing around the world or regions to support research software skills in those personnel. And I gave the link to my slides right at the beginning. I'll just try and paste that into the chat again. Except now I can't get back to my slides that I've done that. Sorry. So you can go and look at any of these links in more detail. My organization, the Research Software Alliance, did some analysis of how people with this kind of focus are recognized in the system. And we identified a range of organizations that have policy in the strategic aims at the highest level of the organization that support this emphasis on people. And there's some examples given there. Chorus also provide an overview of a range of policies, organizations that have policies that support software citation. So increasing recognition of software within publications. Incentives is a great way to support these people, be it in your own team or at a national level or within your community. The French were very innovative early this year, holding the world's first open source research software awards. In the UK, there's also an interest in recognizing these people through awards, although it's not done through the formal UK Research Excellence Framework, or REF, but rather through a community effort called the Hidden REF. Supporting the communities that enable these people to come together and feel that they are not alone, that there are others who face similar challenges, have similar passions and interests, to create networks and share best practice is a fantastic way forward. The research software engineering movement is a movement has been underway for 10 years and has had tremendous successes. There are now national research software engineering groups. Some institutions have their own research software engineering groups, and there is now an international council. There's also been some discussion on how to ensure that people with this kind of skill set embrace the full diversity of people in the community, and a workshop that my organization was involved in early this year looks at how to embrace diversity, equity, and inclusion in research software engineering. The fourth way to support and recognize this kind of skill set is to enable opportunities for people to upskill. The Carpentries have, of course, been running fantastic programs in coding and data science skills internationally for a very long time. There are other initiatives such as the Software Sustainabilities, usually free and online courses at a range of levels. There's new work starting in the US to look at how to train RSEs and also to develop a curriculum or to add to some of the other curriculums that have been developed elsewhere in the world. And Code Refinery is an example from the Nordic or Baltic states who also have an international reach. And lastly, the fifth way that can be used is, of course, infrastructure that makes it easy for us all to do these things. And GitHub had a fantastic initiative last year to enable it, make it easier for built-in citation support so that software is recognized more easily within publications, and thus the people that create them also get that support. And I'd just like to stop here and say that whilst my talk is really about research software skills and personnel, all of these strategies could equally be applied to any kind of emerging digital professional role or skill set. And certainly what would be immensely useful in our community if those conversations began to come together. At the moment, we, to some extent, have conversations about data stewards here, research software engineers over there, perhaps research librarians here, and breaking down of some of those silos so that we're all working in concert to help support these emerging roles would be immensely beneficial. Just to sum up a little bit about my organization. So we play a role in the community as an international coordinating body. You can see our mission there to bring research software communities together to collaborate on the advancement of the research software ecosystem as a whole. So we play a role in helping understand where there are issues, where a number of different groups are focusing on something separately and try to bring them together to provide international solutions that not only benefit those countries or organizations or communities, but also then can be shared for the benefit of all. A few examples of some of our activities. We're just starting a monthly community forum, which is open to all. You can click through to that link and register. We also have a forum of research software funders where we reflect on these kinds of issues and think about how some of the investors in our sector can really work together to address them as well. And you're welcome to join our RISA newsletter subscription, which also comes out monthly. So that's it from me. I hope that stimulated a few ideas on something that you may be able to do in your own context, how you might be able to assist others in your team or your organization or influence national policy to improve recognition of this key skill set and role. Thank you.
Thank you, Michelle, for sticking to the time limit. I believe you have questions related to the presentation, but hold it until all three of our speakers finish their presentation, and we'll take your questions right there. Okay, our next speaker is Dr. Marjan Grootveld. from Dans, the Netherlands.
Thank you very much. Good afternoon, good morning, good evening to you. I'm assuming you can all see the slides by now. Thank you for the introduction, and I think there will be some relations between what Michelle introduced and what I will talk about. But before I tell more about DANS, the organization that I work for, I'd like to share a word of wisdom with you. You probably are familiar with it. The idea is that to give a man a fish, he will eat a day. But to teach a man how to fish, he will eat for a lifetime. It is a wisdom that resonates with me, and I think with many others. And I actually tried if we can convert it from fish to data, seeing that we're in International Data Week. And then it's relatively easy to come up with the first sentence, give someone research data, and they will come up with an analysis. But I struggled with the second part, actually. So I have a couple of alternatives for you. Teach someone how to manage research data, and others can check the analysis. Or give someone a research data steward, and they will produce more fair data in the same amount of time. Or give someone a good research data repository, and they will reuse data for a lifetime. Could you please use the chat to let me know and to let all of us know which version you would prefer, or perhaps you like all of them? I will resist the temptation to look at the chat at the moment, but continue for the sake of time. These three topics, a repository, data management, or data stewardship, training in the area of data stewardship, these three domains, these three topics together form the domain where DANS, data archiving and network services, has been active since 2005. We've grown over the years into an international center of expertise on research data management and archiving. The mission has been from the start to promote and provide permanent access to digital research resources. And we are a daughter of the Royal Academy for Arts and Sciences and the main research council in the Netherlands, NWO. Over the years, we learned a lot from the projects that we participated in. You see here a couple of logos from European funded projects. My focus will be very European and Dutch. I hope you bear with me. There is the logo from the European Open Science Cloud, a number of logos from projects about fair activities, also domain projects like the social sciences and humanities in shock, for instance, Open Air that promotes the open science ambition of the European Commission. And from all of these kinds of projects, we took along both suggestions how to improve our IT services and knowledge and expertise. So and we try to give that back in the form of training and being a center of expertise. We also founded the Data Seal of Approval as a certification seal for repositories and collaborated with other systems to come up with the current Core Trust Seal. And fortunately, our own long-term data repository has been certified with Core Trust Seal. So you see a couple of strands coming together there. It was a coincidence, I'm sure, but two important things I think happened in 2014 in the Netherlands. One started out very local. Technical University of Delft and DANS, we are virtually neighbors, launched a training under the name Essentials for Data Support. It was a foundational training for anyone involved in data support. We wanted to prevent the discussion about data managers, data stewards, information professionals. So we chose the very broad term data support and data supporters. The content is available online, but we also run virtual, physical trainings every year. And we think it is still a good start in this whole area of data stewardship. Which got far more traction, of course, was the notion of the FAIR guiding principles. They actually started in a workshop in Leiden, again, not too far from Delft and The Hague in the Netherlands. And it's one of my small activities in international settings, that to mention that it was a Dutch origin and not in Force 11, much as I appreciate the work that Force 11 did to amplify the importance of the FAIR data guiding principles. We're also engaged in many other activities. There are links on this slide. I'll try to be brief about it because I think you already heard about many of these in the previous days. Dans was one of the, provided one of the co-chairs in the person of my colleague Ellen Leenaerts, the co-chairs for a community of practice of training coordinators. It's being hosted by OpenAir. The other co-host was Irina Kuchma, and it's very popular. I think we now have 120 members from more than 20 countries. At the right-hand side, you see the logo of the Co-Data RDA Schools of Research Data Science. That was an initiative started in 2016. My colleague Louise Bezoutenhout is one of the trainers, coaches there, and co-chairs a mixture of physical schools across the world, from Italy, Rwanda to Costa Rica, but also online schools, of course, and in collaboration with the FAIR project and the EOSC Synergy project. There are data steward instructor trainings as well. And there is a MOOC. So there is a Moodle version of the training with EOSC Synergy contributions. In the middle, you see FAIR again. It is a cover of a handbook published this year, a handbook for higher education institutes on how to be fair with your data, with 16 lesson plans and lots of other chapters and targeted materials. So to support higher education institutions to integrate several aspects related to FAIR into their existing learning plans or to build complete curriculum from scratch. Then colleagues are involved in RDA groups, for instance, in the Education and Training Interest Group, which recently published about minimal learning metadata. And we're involved in a couple of task forces within the EOSC Association. And the most relevant for today, of course, is the task force on upskilling countries to engage in this open science cloud. There are many, many more activities in the world of training, of course, and you will know about those. My question then, as a taxpayer, perhaps I should say, is does it work? Does it bring along more fairness, more open data, better data, and what have you? For this, the State of Open Data report, annual report, is always a good source to see what we know about awareness and implementation of FAIR. What you can see on this screen is that 66% of the respondents in their most recent survey had heard of the FAIR data principles. And 28% said they were really familiar with it. And the pie chart shows, when you add up the blue part and the orange part, that more than 50% of respondents thought that their data were very much or somewhat compliant with the FAIR data principles, which is pretty positive. Also, there is a correlation between respondents who are familiar with the data principles and respondents who reuse data. So that at least allows for the suggestion that data that meets the FAIR data principles is more likely to be reused. However, not all the signs are that positive. There is still concern about misuse of data. And when you look at the percentages over the last years, we see that this concern has grown under the respondents. Likewise, the percentage of respondents who says they never received credit or acknowledgement for sharing their data has grown to 39%, which of course is pretty bad. So we need to do a bit about that. And I don't think this is a technical issue. This is a misunderstanding of what fair is, or obstacles to make data fair. This is more a cultural challenge, I think. And that is where data stewards come in. I'm switching now to a Dutch study that Jeff mentioned in his introduction. We have, I think, as many countries by now, do a national program on open science. And it is related to fair data. We take them together. You see that in the center of the image. And actually we see, or we distinguish, three angles, three dimensions on the route to open and fair science. There is the policy angle with regulations, laws, but also of the ways that funders can steer us towards open science and fairness by the allocation of their money. There are research infrastructures who can provide services that support researchers in their work towards opening up the data and making them more fair. And again, there is the cultural change that we are looking for, both within the research community and the research support community. I'll now focus on the latter part. And originally, the question underlying this study into professionalizing data stewardship was, how many data stewards do we need, where in the organization, and which competences should they have? And there were four main challenges. One about the capacity in terms of numbers. Given the demand for fair data, we think there is still a lack of capacity in data stewardship. I'm well aware that we are a very densely populated small country with, in comparison to others, a huge amount of data stewards. Still, it's certainly not enough for the ambition. Then there is some unclarity where data stewards would be most effective in the organization, perhaps at the level of a faculty, in the research group, or maybe at a more central level. Job profiles are very much unclear. That's no surprise because the jobs don't exist that long, but we really need good descriptions that take into account the responsibilities and tasks, and will also help recruitment when we have these profiles in place. And at the same time, a profile can help to recognize the importance of data stewards and give them a clear view on how they can grow in their job and what career tracks are possible. Focusing again on this part of the job profiles, in the study, we drafted basic components of what a data steward does. Of course, these elements are linked to what they need to know and to be able to do. So you see some purple segments in that circle, like complying with regulations, facilitating good data management practices, knowing about data management IT services, knowledge management in general. So a couple of systems. The universities have their system, universities for applied sciences have another one, and university medical centers yet another one. But fortunately, we all are in discussion with each other. We talk with one another. And while we were at it, we also started to draft basic components of the job profile of research software engineers. The good thing here, which we are proud of, I think, is that the umbrella organization of the universities of the Netherlands decided to include the data steward as a job in the job family called education and research support. So it is being acknowledged in the job classification system. There are actually 4 scales that data stewards work at: junior, senior, and very senior, I would call them. Scales ranging from 9 to 12. And to give you an idea of the bandwidth, policy advisors also start at scale level 9, and PhD candidates in the Netherlands are in scale 10. Clearly, we're very pleased with this practical success that they have implemented our proposal. And over the next few years, we will learn how effective that is. But at the same time, we encountered a new challenge. You see the title of a recent career column in Nature. It's a column written by Marta Teperek, who is director of research, 40-year research data and head of research data services in Delft University of Technology's library. Maria Cruz is a senior policy advisor on open science at the Dutch Research Council, NWO. And Danny Kingsley is associate librarian for content and digital library strategy at Flinders University in Adelaide, Australia. All three of them are senior professionals as support staff. And that exactly is the point they want to raise. Is it sensible and effective to have this divide between the academic staff and the support staff? Quoting from their column, we have straddled the dividing lines between these conventional divisions. As professionals, we make a significant contribution alongside conventional academics. We are well connected with the community. We work in partnership with researchers. We have academic credentials. We write papers, books, grant proposals, and so on. We train students, academic staff. We manage projects. We organize conferences and workshops. So what actually is the difference is the tenor of their column. And they conclude that research teams should not have to fight hard to appoint skilled support staff if their skills and experience would improve the quality or efficiency of the research process. Similarly, support units should not be prevented from doing research and hiring researchers where that would lead to evidence-based improvement of the services they provide. I started with the word wisdom, and actually I'm looking for more wisdom from you, because I will end with some questions. I am still a bit confused about who a data steward actually is and how data steward as a profession relates to what research software engineers does. Michelle has given already a very helpful presentation on that. I mentioned that in the Dutch project, we started to draft a job profile for research software engineers. I've no idea how useful that will turn out to be, so that's open for the future and for discussion. My second question is about sustainability of data steward education. I mentioned briefly the work of the CODASA RDA schools. A key part of their remit is to train especially also data stewards and data scientists in low and middle income countries, and there especially sustainability is a challenge, but it's also a challenge for all these initiatives that pay for training out of project funding. And to my last question from the fish and data introduction, you remember there was a sentence about data stewards and another sentence about good, hopefully trustworthy repositories. And I don't think these are opposites. I think there could be a continuum from human support to IT support. And I wonder if in other countries, which are perhaps not so densely populated or so well provided with the human data stewardship capacity, is there more focus on tooling, and can this also make other communities more efficient, perhaps? I think I'll end here. Thank you very much for listening.
Thank you, Marianne. And also thank you for the questions that you've raised. Those look very interesting. Now I turn to our last speaker, Jevin West. We haven't tested his screen sharing, but hopefully he can figure it out.
Yep, I hope it's working, Jeff. Can you hear me?
Yes, we're working fine.
We'll test it here. Okay. Awesome. Thank you so much, Jeff, for organizing. Thank you to all the organizers. I know how much work it is to run a hybrid conference. I wish I was there in person. Seoul is one of my favorite cities that I've visited. I wanted to be there. So thank you all for joining, and thank you for my panelists. The previous presentations and for the questions that are coming in. I'll just start with one question I saw come in. Someone had said here, I've heard about data librarians. Are they a real thing? And tell me more about those. So I'll just say real quickly, our organization, we're hiring data librarians. In fact, we have a job call that we'll be posting here shortly, and I'd be happy to talk about that. But today I'm going to talk about sort of, I guess, the skepticism side of data. I love data. I teach my students about data. I help run and develop some of the programs at the University of Washington, my university, to train data scientists that go into industry and research. And data is what we get these students excited about. And now they're becoming leaders in their own industries. But one of the most important skills that I feel like I need to teach them, in addition to the skills to learn how to curate and make their data transparent and to make it usable across many different organizations, is really also the ways in which data can misinform. And so I'm going to talk about today some of the kind of key points that I see as someone who actually spends a lot of time looking for the ways in which data misinforms. Okay, so going to my next slide, the main challenge that we have here with data and actually with information more generally is that we're inundated with information. The problem is that so much of it is BS. And we know that now. We know this with the rise of fake news and misinformation and disinformation. But what we also now know is that the consequences are profound. We've seen these kinds of examples of the ways in which misinformation and in misinformation that comes wrapped in data can misinform, certainly during the pandemic and during major crisis events. We've certainly seen it during the Ukrainian crisis. We see it during other crisis events across the world. And so we've done a lot of different things with my group here at the University of Washington. One, like here's an example, we created a game many years ago to bring public attention to deepfakes. So deepfakes are videos that and audio and photos that look realistic, that look as if they're real when in fact they're not. And we wanted to bring public attention to this issue a couple of years ago. So we created a game and we said, here is one image here is real, a real person, and one is not real. One is created using software in our lab that we can create in literally seconds. And we play this game, people play it, and they realize how hard it is to distinguish real from not real. And it certainly scares me. I've played the game many times and I still fail at the game. And by the way, just so you know, the person on the right is the real person. The one on the left was created with computer software using some of this GAN-generated technology that's now been around for several years. And actually, some of the technology was developed at my universities for better or for worse. And the reason I bring this up is that there's means and mediums of communication that make deciphering what's real and what's not difficult. And a lot of the attention sometimes is on this kind of technology. It's on GPT-3 and auto-generated text. There's a lot of excitement around OpenAI and DALL-E, the game, or DALL-E, the technology maybe you've seen over the last week or so. And sometimes too much attention gets focused on the newest, greatest technology for making it hard to tell what's real or what's not real. But I want to talk about another kind of information, and that's quantitative information that's generated from all the data that we get excited about at International Data Week and in our organizations that work with International Data Week. And a lot of that information can be just as misinforming, if not more, than any deepfake that's out there. So let me give you an example from our president's office. I'll show many examples. Most of them are US centric, but I have even examples. A lot of examples. I could probably dig from my folders that come from South Korea as well. We have them everywhere. No place on this earth is escaped of data examples that can misinform. But this was a chart that was generated by the White House in the United States, and it was looking at Americans' economic growth. And if you look at the chart, you see this really big white bar to the right. Looks impressive. And actually, to be honest, it is impressive. You see how much that it's gone up. Let's assume that the numbers that they're reporting are correct, and it's actually was in 2021. It was to 5.7%. But if I was there in person, I would sort of allow for a raised hand and say, what's wrong with this particular, what's wrong with this particular example? And if you look closely, and I hope you can see it closely enough, you'll see that on the y-axis, there has been a spread of 0.5 at the very top of the chart. Whereas in the rest of the y-axis, you see it being spread by 1 unit. And so what that 0.5 unit spread at the top does is it makes the white bar on the right look bigger than it actually is. Now, they didn't even need to do that because 5.7% is greater than much of the rest of the previous years. But it's these kinds of things that we want to train the next data scientist, whether it's in industry or research, to be on the lookout for. And these things aren't necessarily all that complicated, but we need to create these habits of mind to pay attention to these kinds of things. Now, this wasn't isolated, of course, to our current White House. Our previous White House in the early parts of the pandemic was bragging about the massive increase in tests being completed in the United States early on in the pandemic. And if you look at this, this does look impressive. You see these massive increases in the numbers of testing in March of 2020. You see this March and then into April, it's going way, way up. It looks impressive, right? Well, the problem here is that the White House, the previous White House, was using a cumulative chart. And as I always tell my students, if you want something to look like it's going up, always use a cumulative chart. But please don't manipulate, of course, in that way, but be on the lookout for those things. And actually, if you were giving this chart and your users knew that it was a cumulative chart, they wouldn't be actually impressed in the number of tests that were being pushed out during this particular time in the pandemic, because you weren't seeing increases from one day, or in this case, days, this is in days, from one day to the next. But this isn't isolated certain to government offices. This happens in industry all the time. When Tim Cook took over Apple many years ago, he was talking to his shareholders and to his fan base at one of their annual meetings about the explosive growth of iPhone sales. And here again, you see a cumulative chart, and it looks impressive. But again, cumulative charts always go up, and a more apt representation would have been probably to look at quarterly sales. And quarterly sales in this case tells a very, very different story. So as we create these data sets and make them available, to make them usable, to make decisions for us, we need to make sure that the data representations are accurate reflections of that data. Now, a lot of this is very basic, and I'm focused on mostly data imagery examples, visualizations, which is our way of speaking in data. But this, of course, applies to many, many different kinds of situations. And my colleague and I, Carl Bergstrom, teach an entire class about this that involves all sorts of other concepts like selection bias, correlation, causation, et cetera, et cetera. I'm just focused on a few since I want to make sure I wrap my talk up in 15 minutes. Now, let me give you one more example, and then I'll talk about some of these other kinds of important concepts when trying to develop the skills of the art of skepticism in a data-driven world. And that is, here's this chart. You see again that it looks like carbon dioxide emissions have sort of leveled off. And if you look at the text to the right, it says over the years, carbon dioxide emissions worldwide had stabilized. Now, that didn't seem quite right. I guess it could be if you looked at the data. And you could tell all sorts of stories in looking at this particular chart. But instead of focusing on the y-axis here, let's focus on the x-axis. And here you see in the early years, 1751 to 1781, 1811, that the separation is by 30 years. But if you look at the end of the y-axis, the x-axis, you find that it jumps from 30-year increments to 1-year increments, 2011, 2012, 2013, 2014. And like I tell my students, if you allow me to manipulate those kinds of things, I can make a chart look however you want it to look. And so here's a situation where, as a data scientist, you might wonder, should I share or beware of this particular chart? You're looking at two charts. They're exactly the same data. The only difference with the chart on the right is that it's evenly spread throughout the time period. And again, look how different those things look. And when you post these kinds of things on Facebook or Twitter, you give a very different impression of what the data is telling you. And so again, these are the kinds of things that we need to be on the lookout. Now, this comes in other visual representations. Here's a heat map that was pushed out by the Georgia State Department of Health. This is a health agency in the state of Georgia here in the United States that was putting out heat maps looking at the differences from one time period, differences in cases of COVID from one time period to the next. And if you looked at these two heat maps, you're looking at the counties within this state, it doesn't look that different. And if you were trying to make policy decisions based on this data that's been collected in the state of Georgia, you might think, well, things are okay from July, from these two dates in July of 2020. Well, they can't be compared. And one of the things that we tell our students all the time is you need to be able to compare when doing these kinds of analyses. And certainly when you're pushing out policies from your government offices. And here the problem here is that the bins are different. Again, if your bins are different, you can't compare the two. And they might look the same visually, but if your bins are different, then of course you can't really make those comparisons. Now, this is and to the credit of this particular agency, they recognized the problem when many people came out and said, look, your bins are wrong. They actually said, we made a mistake. They even, and I appreciate that sort of thing. They said, well, the software we were using was automatically scaling the data that we had. And in that case, it may have actually been true. And it's one thing that I remind our students is that it's something called Hanlon's razor. Excuse me, that you never ascribe to malice what can be adequately explained by incompetence, and never ascribe to incompetence what could be understandable mistake. So in this, in this journey of becoming a good skepticist of data, we need to make sure that we're being very careful about ascribing malice to what we're doing. So I'm going to end my last part of my talk by just saying, what can we do about this? Now, we have all sorts of efforts at my university. My colleagues and I started what's called the Center for an Informed Public, where we really study this issue of misinformation. I spend most of my time on science misinformation and data misinformation, but we study all sorts of other things. We look at macro patterns of misinformation and disinformation online, on social media, not just in the United States, but across the world. And then we share our results and look at the ways in which people are amplified online, how certain ideas go viral, how some other ideas don't go viral. And a lot of times that information comes in data. But really the thing that I've noticed over the last 10 years or so in teaching data science classes is that I don't think that we're teaching our students to question numbers in the same way we have them question other forms of information. And partly it's because numbers appear to carry authority. They're objective, they're precise, they seem like they come from science, and in many times they do, but it really sometimes makes people not question them. And that's why 37% of virtual talks include made-up statistics. Now that's a joke, of course, but we do have a website that we teach, and we make this information available and these lectures available. You can go to callingbullshit.org and learn about some of these kinds of lessons that we talk. We also have a non-swear word version if you don't want the swear word version in it. This is being taught at universities around the world, which is very exciting. We have a book, and as Jeff mentioned, it's been translated into Korean. We're very excited about that. Some of my Korean colleagues have looked through it and says most of the translations seem correct. If there's wrong, please let us know. We also have a Twitter account that we put out examples all the time if you're looking for ways to get better at this sort of thing. But one of the things that we want to teach is we want to teach people to focus in on the data input and less on the black box algorithms and statistical procedures. Yes, problems occur there, but most of the time it's in the data input and it's the interpretation of that input. That's one of the most important slides right here. And we teach it in our book and in our course. And in a lot of the work we do in training data scientists to focus on the data input. That's where most of the time the problem occurs. I don't have time to go through all the rest of these things because I want to wrap up in the next minute here or so. But I do want to say there's lots of different concepts that we talk about when we talk about developing the ability to be skeptical of data, but of course, be using data in good ways. So I'll just give two examples here of things that I think are very important that I'd be remiss if I didn't include this in this lecture. And one of them, of course, is teaching data scientists to learn about selection bias. And selection bias is when you sample your sample differs systematically from the population. So let me give you an example from COVID. there was an article that went viral. We were studying these kinds of articles that were going viral. And one of them was from a set of dentists from New Jersey that were claiming that the use of masks were leading to poor hygiene. And they made that argument based on patients that were coming to their office. They were seeing relatively more patients with severe issues of dental problems like cavities and real pain than just regular checkups. But of course, this is a selection bias issue, because who's going to go to the dentist at the beginning of a pandemic when everything else is shut down? The only ones that are going to go are ones that have such severe pain in their teeth that they can't even sleep or do anything. So they're going to see more of these. So this is, of course, an example of the kind of selection bias that we see in the media and in science even constantly. Now, let me talk about another important concept, correlation causation, to wrap up my talk. But this is, everyone thinks they know the difference between correlation and causation, but we all struggle with this. A third of this, there's an article that was published that showed of all the 50 most shared research outcomes, a third of the journal articles misattributed causality themselves. These are the researchers themselves, and a half of the news articles about these also got it wrong. So we get it wrong all the time. And here's this is the last example I'll give. This was another article that went viral. This claimed that bald men were at higher risk of severe coronavirus symptoms. And the hypothesis was that baldness was sort of leading to, because of endocrine involvement, into COVID pathogenesis. And they were published in a legitimate journal, Journal Academy of Dermatology. It has had all sorts of explanations, fancy figures like this, but they made one big mistake, and they forgot the common cause to these kinds of things, which is age. Age causes baldness and also COVID risk, which was likely the driver of these associated variables. And Forbes and other national and international news agencies had to retract their reporting of this because they forgot to include this. So these are the kinds of things that we're looking out for all the time. I'm going to skip the last example, but I'll just say that not only can humans be misled by data, but of course, AI can be misled all the time too. And there's a great paper I wanted to mention here. I'll just leave the paper up, that essentially makes a similar mistake as the previous one that humans make and that journalists would make and that researchers would make themselves. But here in this case, there was a problem with being able to, the idea that AI could look at radiograms of the chest and tell whether someone had COVID. Well, it turns out that it was really due to other factors in the image of those radiographs that were really related to hospital rather than the entomology of the disease. So I'll end here by saying International Data Week celebrates and pushes the value of what we can get with data and how we make that data available and how we use that data. And I'm a huge advocate of that. But we also have to make sure that we're questioning the ways questioning the data that's put in front of us and how we present it. And it reminds me of one of the most important laws in bullshit studies, if there's such a thing. And that is, at any given time, the chief source of bullshit, which we have to watch out for, is ourselves. So as data scientists and data engineers and data providers, we need to make sure that we're presenting data in ways that make for good decision making. And with that, I'll end, and thank you so much again for joining. I hope to see you all in person at some point at another conference. So thank you so much.
How wonderful. So he was able to finish his presentation almost in time, but he also gave us a few chuckles that we really need. Okay. All right. So we still have about 30 minutes, 25 minutes for Q&A. And I believe, given the number of participants who joined online, about 75, and there are about several dozen people here, we got to have some questions. Otherwise, I'll ask a lot of questions myself. Okay, I'm going to look at the chat window, and also we're going to look at the Whova chat window because questions come from both of these channels. Okay. All right, from Sarah Jones. How do we scale up the provision of these support roles, be it software engineer, data stewards, and something else, and also professionalize these roles to provide proper career opportunities? This is a really important question. but probably cannot be answered in one single sentence. But I'd like to turn this question to either Michelle or Marianne.
I'm happy to start off with an answer. And I guess there are two main ways to do it. The short answer is we don't know, but there are two main approaches. And one is to think about upskilling researchers so they can do a little bit more of this themselves. But there's also a recognition that there's already huge demands on researchers to have a very wide variety of skills, and that they can't become specialists in all of these digital skills. So there's some emphasis on increasing researchers' abilities, but also as a complement, there need to be an increase in the number of people with those roles. I guess there have been quite strong suggestions at times on how to do this. There was I think a Nature paper some years ago that suggested that, sorry, I'm now going to get the figure wrong, maybe 5% of all research funding should go towards research data management, and certainly if that kind of thing ever happened, then it would be much more possible to upscale the people that do have that kind of specialist function.
Okay, Marianne? No, okay.
Yes,
right.
Thank you. To add to that, I agree with those, and I would also make a plea to include other contributors to science. You're probably familiar with the contributor taxonomy of Casray, which also mentions people like the data curators, but also the people who acquire the research projects, the people working in a laboratory. So when we are discussing this question, I think we should widen it out to include them. Okay. And I don't provide an answer, as you hear.
We have a question here in the room, and
Hi, it's not actually a question, it's a response to the previous question. Sorry, I've got a bit of echo. James Wilson, University College London. So we've been recruiting research software developers for about 10 years now, and we've grown our number of full-time developers to 40 by simply costing them into funded projects. We actually can't keep up with the demand. We cannot recruit fast enough to meet the demand we're getting from our researchers within the university. We've now started doing the same thing with Data Stewards. We only have one so far, so we'll see if it works equally as well with Data Stewards, but we've not had problems. The problem is getting researchers to realize that we have these staff who are there to help them at the right point so they can be costed in. And the other problem is recruitment, but actually paying for them, we're not finding that difficult.
Okay, so I believe that is more of a comment than a question, but appreciate it. Okay, here.
Yeah, hello.
Can you also say your name and affiliation? Okay, before you do that.
Barend Mons, Codata. And it's going to be a question to challenge Marianne a little bit on something, but I know her opinion already, so it's a safe question, then I know the answer. But I think that I would like also to react a little bit to a number of terms that come around, because when I was recently in a defense of the first PhD that was entirely unfair, Martijn Kersloot, also, he was a Dutch guy, he did also a survey, and he separated the knowledge about FAIR in two categories: the doctors that he recruited in a slightly biased way, and they had a very high response. So, 80% said we know about FAIR, and we know what FAIR is. And then he had support personnel. I will come back to that. And then the next question, and they also were around 80%. And then the next question was, what do the letters stand for? And the right answers in the doctors dropped to 30%. And in the support personnel, there was still 70% that actually knew what the letters meant, although they answered the first question positively. So that leads to 2 points that I wanted to challenge you on, and maybe even Sarah, because I would think that the consequence of your talk, Marianne, and also the paper that Marta and others wrote in Nature, and the one on 5% for data stewardship that I wrote, means that we have to do two things. Stop calling data stewards support personnel. They're not support personnel. They are a fully fledged partner in any modern research team. That also means that they would detect all these numbers much better than the average scientist. And Marjan, then it comes to the question, could you answer to what the consequence is for training? If we try to train every scientist of the future as a half-baked data steward, that's going to be going nowhere. I think they should be consciously incompetent and hire one data steward at every 20 data spitters. But what is your reaction to that, please?
Okay.
Hi, Barend. Good to meet you in this arena, Barend. And indeed, we know one another and we know a bit about our own positions. Having said that, I think that a lot of researchers can learn a lot of data management, good practices, in the same way that researchers have been able to learn how to write academic publications, for instance. You're not born with that kind of knowledge, but you learn it on the job. I think we should not overvalue data management. I'm not sure if my boss likes me saying that, but anyway, I think it's part of the job when you work in research and science. So that is one part of my answer. The other part is, yes, I think we need specialized people who know more than you can learn on the job as a researcher. Personally, I don't mind how we call them. I was quite happy with data supporter, but I'm completely willing to move along with other developments. So there are, don't think I will give a real answer. When it comes to how do we train them or how do we scale up training, I don't have an answer. It will take time, it will take effort. I think it will take more effort also to do it in a didactically sound way than we sometimes do it, because a lot of the trainings and bits of curriculums that are now being developed and used are developed by the data support professionals themselves who may not have that didactical background. So that's also one of my concerns. I think this was halfway of an answer, Barend. Maybe we continue the discussion at the moment.
Okay, wonderful. I believe we have one more question from the floor. Then we'll switch over to questions from online chat window. Okay.
Hello, Hugh Shanahan, Royal Holloway and coordinator RDA Schools. Marion, Michelle, your two communities, I would argue, are two sides of an exquisitely valuable coin. What do you think are the lessons that you could learn from your opposing communities?
I can try and start. So yes, a fantastic question. And it's very true that there are some advantages in the fact that data stewards and research software engineers have developed as movements to some extent separately, because it means they've got different strengths. So for example, research software engineers have done an excellent job of getting recognition of that title and developing an international community, and this whole structure, as I mentioned, of national associations, and then beneath them, sometimes organizations in a country have their own networks, and then an international council of research software engineers. So there's been fantastic benefits there. I think I would probably try not to attempt to speak too much to where data stewards have done better, but I think there's been much more work done on curriculum development and skills programs, and some thought about how to professionalize that. But I would really like to emphasize that this discussion should be about so many other roles in the research sector. As I mentioned, research librarians or laboratory technicians, so it's not even digitally focused roles. It's community managers or, the people who specialize in ethics or enabling qualitative analysis, in a team science environment. It's really a team science environment that we need to be looking at holistically.
Yes, and if I can continue on the team science, so we know about some good practices already of those teams where the research software engineers and data steward professionals collaborate with a different strength to support research community and perhaps other external customers. So that is working well. My impression indeed is that data stewards have a bit longer tradition than of organizing themselves in communities and sharing knowledge than the research software engineers. Yeah, but drawing real lessons, I find it hard. You?
Okay, so I hope I'm not alienating for those of you who are participating online, because I took 3 questions in a row from the floor. No, I do not want to alienate Dr. Jevin West. Okay, all right. So can you, the operation team, can you pull up our Q&A window? All right, there is one question. Critical analysis of evidences and data is part of scientist life education, but not all of all citizens. Do you think that critical view on data and caution with numbers and their representation should be part of basic education of children more than it is? Any idea for journalists?
Yes, so I can take that, Jeff. And before I take that, so thank you for the question, Anne. I see this is a perfect question that I'd love to address. I just wanted to mention a couple things based on questions that were just asked as well. Here at the University of Washington, we just received $40 million in collaboration with the Georgia Institute of Technology, with Johns Hopkins University, with the University of Cambridge, to build essentially a scientific software engineering center. And so we're in the early stages of that in our eScience Institute, which I've been a part of as a faculty member, to develop a center devoted to essentially bringing in sort of industry level software engineers to develop software for scientists. And so everything that's being said here is really important for us, and if we'd love to collaborate with others on this particular issue. But to this question that's really important to me, thank you again, Anne, for this question, because I do think we need this more than ever for journalists, and I talk to journalists almost weekly about this, and we certainly need it at the early stages of education in children. And what I have found is that university students aren't prepared for this, and certainly even the researchers themselves and scientists could always use more help when it comes to data reasoning, and partly because data and the technology we use that interacts with data is moving faster than our education. And so there are efforts right now in many different countries around the world to bring data skills earlier to students, certainly earlier than when they reach the university level, but we're still behind. And I think they're already full curriculum, and so there are only so much time we have, but I think it's some of the most important skills that we should give, and especially to the journalists that don't get that kind of formal education in their program. So I absolutely think we should do that. We have programs, and I'd be happy to talk to others about some of the programs that we're developing right now for children in grades 5 to 12, and certainly at the university level, where I spend most of my time, and also for the more technically adverse or technically apt individuals that are in the research world on what they can do to continue to develop their skills. So yeah, I definitely have that as well.
Thank you very much. I heard that our Hoover chatting room is just teeming with a lot of comments and questions. Let's pull up those. Okay. Whoa, this makes me dizzy. Okay, so whistling sound. Okay, so I think you kind of referred to this question, Jevin. In another talk this week, I heard about data librarians for the first time. Would they be, I'm surprised. Would they be data stewards as well? Can any one of you tackle this question? Or
I'd be happy just to say in practice what it looks like for us, and then I'll turn it over to my fellow panelists to add to this. So data scientists, I think, are playing multiple roles, or data librarians, sorry, are playing multiple roles, both as stewards, software librarians. I mean, it spans the gamut right now, depending on the university or organization that are hiring these individuals. But I'll give you an example. So right now, we share a lot of resources with centers across the United States working on this issue of misinformation. But the problem is, collecting and curating this data from these large social media companies, making this data available, doing all the things that we talk about in this conference, of course. And we're looking to hire someone to help sort of facilitate that kind of work. And these are individuals that might have training in the information sciences, have some technical training, could write software. Some don't necessarily have to write software. I guess the main thing that we're struggling with is, what don't they do? So actually that's, we're now using the term and we're putting it in a job description, but we're struggling actually in that job description on, wait, we know what we want them to do, but we need to also note what they don't do as well. So that's something I think that we'll have to figure out if we continue to use this term.
Oh, that's a very interesting way to put it. Yeah. All right. Another question from, okay, Jevin, send your email address. Okay. Next.
I'm posting that right now.
Okay. Okay, can you go down a little bit? Okay, regarding less favored countries, while there are often collaborations and even twinning for scientific purposes with more favored countries, institutions, could we imagine twinning, pairing for mutualization of data steward professionals? Actually, in many, I'm involved with international standards organization, and there's a lot of twinning going on. So I think the person is asking about the possibility of those kind of mechanisms or arrangements. I can say that, I went to a couple of sessions related to education issues, and most of these trainings and tutorials, they offer their materials online freely. So that's one way to share. But in addition to just sharing these materials, I think there's got to be a way for working closely with people in other countries, I guess.
Yeah, if I can add to that, and then I would refer to, for instance, my colleague Louise Bezuidenhout or Hugh Shanahan in the live audience. I think the way that the CoData RDA schools work with people who have been trained in one of the trainings and who can then become a helper in the next training is a kind of asynchronous twinning, you could call it, taking on the knowledge for a next situation and be trained the trainer, gain on that quality. So maybe it's not a twinning or the pairing that you were asking about, Anne, but perhaps this could also work.
Okay. All right. Can you go back? Can we go back to the chatting, not this one, but from Hoover? Yes. Not this one. Okay. I'm searching for questions here. Okay. Right. So looks like many of them are comments. Okay, you can still go down. Okay, you can still go down. Okay, a lot of interesting discussions. Okay, metaphor. Okay. Okay. All right, so this is all you have. Like, you have all this in your record. You can come back and enjoy it for yourself. Okay. All right, the time now is 5:20 here in Seoul. I think we can finish a little bit early, or otherwise I want to give each speaker an opportunity to give a parting shot, if you like. Yes, Michelle.
Sure. I'm happy to challenge the audience to think about, what I see as the central bigger problem of how do we bring together these discussions about so many different roles and have a united conversation about recognizing them all as part of team science.
Wonderful.
I just want to thank you, Jeff, for organizing, and the organizers of the whole conference. Thanks for having this, and happy to continue this conversation after this recorded event occurs. So feel free to reach out anytime, and especially if you're interested in the ways and we teach people how to be good data translators into the public.
Thank you. I'm really sorry for keeping you up awake at this hour. I'd love to go back to Seattle with my students in January next year. Okay, Marianne. Okay.
Yeah, I think I support both my fellow speakers. Compliments to the chair and to everyone for the discussion and questions. And I really support the idea that Michelle also mentioned, that we not focus strictly on data stewards and or research software engineers, but look at a whole bunch of people we collaborate with, we work with, we benefit from, and see how we can scale all this quality up in whatever kind of balance or mixture in the team.
I totally agree with you, because I picked up so many resources and training opportunities in so many of these sessions, and it's very difficult to wrap it all around my head. So it looks like, we need some kind of clearinghouse for these training opportunities and materials and so on. All right, I thank everybody who have participated virtually or on-site for your patience and interesting questions and comments. And I would like to, first of all, thank all of our speakers for giving us a really good insight and interesting talk. Thank you very much.